where it crosses the x-axis. Yes, sir. Depends on how much you remember from Algebra 2. I mean, Algebra 1. Possibly.
What's the next quiz?
This and the next thing. I don't know. Sure. There wasn't a lot of work to show for this, no. You just have to be able to calculate those zeros on your calculator. Yes. Why don't I do one of them on the calculator? Okay. We're still a little ways out. No, it's possible tomorrow, but it's probably going to be next week. Yep. Yeah. Be happy. All right. Let's see. Depends on how it's broke. Fix it. How? Define fix. Hit second mode. Quit. Did it quit? Is it unfrozen? Mm-hmm.
That makes sense.
I even took the batteries out and put them back in. Yes. Now, it's not a study guide that looks exactly like the test or anything. It's just concepts when we go through. But yeah, we do a study guide. Yes. But it'll be everything. And I'll give you the answers to it. We'll work. That's all we'll do in class today. I don't know. Haven't finished making the test. All right, what'd you say, 2 and 5? All right, number 2. Number 2 is negative x squared. So I'm gonna put that in here in y equals. So if you hit the y equals up here, x to the second plus 2x minus 3. I'm going to hit zoom 6 because that gives me a standard window. A standard window is a 10 by 10 window. So if you think about a graph, it's going from negative 10 to 10, negative 10 to 10. Or you can just hit graph. It's probably going to automatically be, uh-oh. What did I do? Everybody okay? Error. Why does it keep doing that? Okay, hold on. Somebody's probably messed with this. Okay. They were. See if I can figure it out. It's probably Cade. All right, what should I do now? Second trace, so I'm going to go second trace. That's going to pull up this command that says calculate, and then I'm going to choose. So there's two things that we've been going between here, zeros and maxes and mins, right? Zeros is what I'm looking for because those are my solutions. That's what I want to find. So I'm going to choose zeros. And now let's focus on this first one. I'm going to go over. I was told I didn't do a good job explaining this yesterday, so let me try this a different way. Put your spider on the point you're trying to find. Okay, and when it says left bound, click left 3 times. 1, 2, 3, and hit enter. So on it, left 3 times, enter. Go back to it, and then go right 3 times because it's telling you. I say 3 because generally that will clear what you're trying to pass there, the 0, and hit enter. Now, do you want me to guess? Yes, so I hit enter one more time, and it should calculate it for me. So to the left of the point, to the right of the point, and then enter. Does that make sense?
Yeah.
To the left of the point, to the right of the point, and then hit enter. Let's do the other. So now let's look at this one. Again, second trace, which is calculate, and I'm going to choose option 2 for 0. I'm going to put the little spider close, and then I'm going to hit the button to the left about 3 times and hit enter. It doesn't matter how many. I generally say 3 just because that will make sure you're good and past the point you're looking for. But it doesn't matter. And then you hit enter one more time, and it should calculate that point for you. So the solutions to this were -3 and +1. I would put, writing these out since you're looking for solutions, I would say x equals 1, and I would say x equals -3, because they're both solutions to the equation. They're what x equals to make it true. Then you said number 5, I think. What in the world is going on? Oh, she's talking to somebody. I didn't see the teacher out there. Okay. Number 5 is x squared minus 9. Now, before we actually graph this, just to show you how this comes full circle, how would you factor that? What do you notice about that? They're both perfect squares, so it's a difference of squares. So how does it factor? So where should this be crossing the x-axis? +3 and -3, because I set each one to 0. I should get 3 and I should get -3, but let's look at the calculator and let's see if that happens. So y equals x squared minus 9. Looks pretty good, right? If I calculate, so second trace, 0. I'll start over here on the left. 1, 2, 3, enter. Back where I was, 1, 2, 3, enter, enter. -3. Do what? If I do the other one again, left, 1, 2, 3, enter. Back to the point, 1, 2, 3, right, enter, enter. And positive 3.
Wait, so you have to go left, right.
Yes, and then enter a third time. Yep. 7. 7 is negative x squared. So when you put a negative in, be careful on here because minus and negative are two different things on your calculator. And you'll get a syntax error if you get them mixed up. So this is the negative button. This is the subtraction button. So if I want to say negative x squared, I'm going to do the negative under the 3, x squared, plus 8x minus 17. Graph it again, or zoom 6 so you get that standard window. What do you notice? There's none, right? There's no x-intercepts. It's never on the x-axis. So I say there's no solutions here. So this would be a no solution. If you tried to factor this, this would be a CBF. Right, Logan? No solution.
I wrote no real solution.
That's correct. Yes. Sometimes you'll be asked to find all real solutions. Sometimes you'll be asked to find all solutions, and those are two different things. So this one has no real solutions. That's correct. Anything else? Going once? Twice? Sold. All right, let's start today. You need your notebook. Somebody asked how long today was going to take, and today is going to take, it depends on how much you remember about radicals and solving equations from Algebra 1 as to how long this takes for today. Yes. Pretty good. Simplifying radicals, you're pretty good. I tell you what, Charlie, I got one for you. Simplify that radical. Too easy. I'll give you just a second to catch up with me. What?
Nothing.
You get it?
Yeah, there's a 5 and I got 2 of them.
How'd you get it? Your calculator does it. What do you have in your lap? What did you do? Stand up.
Photo man.
Now you do.
Stop cheating, Charles. It doesn't help.
Tell me, okay. Tell me how you did it. That's correct. Yes. Yes. All right, so here's what I'm going to do whenever I simplify radicals. And if you remember this, and I don't need to go into too much detail, then tell me and I won't. If you don't remember, don't be afraid to speak up so that I can explain it in a little more detail so that you understand, because you will have to be able to do this. When we simplify radicals, remember we are looking at the number under here and we are trying to find the biggest perfect square we can that we can divide that number by. Okay? What do I mean by a perfect square? Right. So we're looking for things like 4, 9. This is where y'all say 16.
25.
25. 36.
49. Oh.
be able to recognize at least through there. Okay. Now, those are my list of perfect squares, right? Because 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, and so on and so forth. So I'm looking from that list of numbers, the biggest one that will go evenly into 50. Do y'all remember doing this, or do I need to go back as to why and everything? Okay. Yes, yes, yes. Because here I could break this up. Radicals have this neat little property that says if you're multiplying, you can split up into two different radicals to multiply, and that's essentially what we're doing here. So you said 25 times 2 is the same thing as 50, right? We chose 25 because it's the biggest number from this list that goes in evenly. They're both under a radical, but the square root of 25 is 5. So I get 5 times the square root of 2, and that's how I simplify that radical. Does that make sense? We all remember how to do that? Don't need to. Somewhat? Yes.
So, like, it will work. I can say it a different way. Like, I get square root of 25 times 2 square root of 5.
Fine. Don't be ugly. It's fine. That's fine. Yes. Let's say try that one. Simplify that radical. So what you got, Kay? You don't need a calculator for this one. Anybody get it?
Oh,
yes. What's the biggest perfect square you can divide 90 by? 9. 9 times what is 90? 10. Square root of 9 is 3. And 10 stays. If you can go from here to here, as long as it's an easy one, that's fine. No, because once you take the square root, you have to drop the radical. So once I take the square root of 9, so you're dropping one off the perfect square. I can tell we need a little practice with this. Well, 2's outside the radical, but remember that property that said this times a times b equals the square root of a times the square root of b? I can go this way with it, but I can also go this way with it. So I can put them together if they're in the same radical. So we might need to go that way. I think you just did it. I think you just said that, but you just didn't. So I'm going to instead, since I can't break this down or anything, what I'm going to do is put them together in the same one. So I'm going to say this is the same thing as 2 times the square root of 40. Oh, okay. I got you. Now what I want to do is I want to see if I can break this up in what and what? 4 and 10. So I have 2 times the square root of 4 times the square root of 10. Well, what's the square root of 4? 2. And this is all being multiplied, right? So 2 times 2 times the square root of 10, which is 4 times the square root of 10. Can I divide that anymore by any other perfect square? That's how I know I'm done. You could, but you're going to make more work on yourself. So if I had done this and I said 4 and 2, then that would have given me 2 times the square root of 5 times 2 times the square root of 2. I'd had to multiply these two together and then multiply these two together. So it'd been more, but you can, if that makes sense to you. What if I told you that that was only half the answer? Define a square root. In other words, the square root of 25 is equal to what? Or why? because I said so. Why do I have to include the negative? What is, by definition, what does it mean to be a radical or square root? By itself twice. 5 times 5 is 25, but negative 5 times negative 5 is also 25. Are y'all okay? Y'all need to stand up and stretch or something? Y'all are not very lively today. Do y'all need a break for a minute? We need to make sure that we follow up with a plus or a minus. It could be positive or it could be negative. You don't need that. You don't need that.
You won't. Do it. You won't. $5 says you won't do it. Okay. Put it in your ear and give yourself an earring.
Welcome to kindergarten with Miss McGee. Oh my
Hey,
gosh.
your other class is probably worse.
What? Last semester, second block?
Yeah.
Nah.
They were better?
Yeah.
They were definitely worse.
All right. So I'm going to throw a plus or minus. Don't forget the plus or minus because then you have half the answer and not the whole answer. Okay. Every single time you take a radical, take square root. All right, look at the sheet that I just gave you. Let's run through a couple of them. We're going to run through some of the, this is not necessarily homework. Just hold up. I haven't decided. We're going to see how far we get because, oh no, we're going to have homework. I just don't know if it's going to be this sheet or the other sheet that I ran. All right. Actually, before we look at that sheet, let me show you the other property. Yes. So I told you that one of the properties was this. The other property that goes hand in hand with this property is the division property. And it says that if you're dividing under a square root, then you can split that radical up to the top and the bottom. And again, I can go forwards or I can go backwards with that either way. So if I end up with something like number 4 on your sheet, where I have the square root of 4 over 9, what does this become? That's right. I can do the square root of 4 over the square root of 9, which is 2 over 3, and I still need the plus or minus because I still took a radical. I can still see your phone behind your sheet. Right? Okay. I don't even have strict rules about that. It's just the fact that you're like behind it hiding. Okay. Yeah. Thank you, Hank. Thank you. Tell him. Tell him. All right. What about number 6? Once you find what multiplies to that, you drop the square root.
What's that plus minus thing? Yeah.
You always follow a radical, you always precede a radical with the plus or minus. It just tells you that it could be, that means that it could be 2/3 or it could be negative 2/3. It could be the positive or the negative value of that. What do you get here? 6/11. That's right. Plus or minus 6/11. Now, I'm going to take this one step further, and this is not on this sheet because this is an Algebra 1 sheet. So stay with me because this might be a little bit new. Sorry. You cannot have a radical in the denominator. It's a rule. Just can't. Kind of like you can't divide by 0. Makes it undefined. You can't have a radical in the denominator. So the question is, what do I do whenever I have a radical in the denominator? Okay, how? So let's say I have The square root of 3 over the square root of 2. Okay, close. Okay, you're saying it wrong because you can't just do this to the top and the bottom because then I've changed the value of the fraction. The fraction value itself has to be the same. So what I'm going to do is I'm going to multiply the top and bottom by the same thing, because multiplying by the same thing, if you divide something by itself, it's 1, right? Multiply anything by 1, it keeps the same value. So I'm going to multiply the top and bottom by the square root that's in the bottom. And that's kind of wordy, but whenever you see what happens, you'll see why. The square root of 2 is the problem. Do we all agree? What is the square root of 2 times the square root of 2? 2, right? Think about this. The square root of 2 times the square root of 2. If I put them together, that would be the square root of 4, which is 2. Square root of 5 times the square root of 5. In fact, could we generalize it like that? Yes. Does that make sense as to why? Thank you, Logan. Makes sense to Logan. Does it make sense to everybody else? Yes? Okay. So here, the square root of 2 times the square root of 2 is 2, and the radical's gone out of the bottom. But if I do it to the bottom, I have to also do it to the top. So I'm going to multiply by square root of 2. So what does the top become? Square root of 6. Then you try to simplify, but 6 can't be broke down, right? There's not a perfect square that you can divide 6 by. So I'm going to stop. I am going to throw. You can't do that because the 2 is not under a radical. If the 2 was under a radical, you could. Yes, half credit. Because that's half the answer. Well, lots of people will forget on the first quiz. You'll lose half credit on every answer you forget to put it on there, and I guarantee you don't forget again. Let's do another. This is called rationalizing the denominator, by the way, in case you wanted to know. I don't have to know that, but just to let you know. Simplify. Simplify. This was not, I did not anticipate doing this today, so I'm sorry I'm going off cuff here. Okay. Uh-huh. Because it didn't split up any, so I had to multiply by square root of 2, right? So I used this property that went backwards, the square root of a times the square root of b. I put them under the same radical. And then I would check to see, can I split it up at all? The question mark. W question. What's the problem or what's the issue?
We have the radical.
The 7, the radical, and the bottom, right? So to get rid of it, I'm going to multiply the top and the bottom by what? That's right, square root of 7. The top becomes what? Square root of 35, and the bottom becomes 7. Can I divide those now? Can I say 35 divided by 7? No, because the 7's not under a radical.
Why is it not?
Because this equals 7 without a radical. Because 7 times 7 is what? And the square root of 49 is 7. Y'all tracking with me? You're this way? What does that mean? Oh my goodness.
What's wrong?
I said, the other direction. I don't know what that means. Yes, that is the answer. That is the answer. Oh, kudos to you. Good job. You do need the plus or minus. I would have. You are correct. Try number 12. Y'all try number 12 on your own, then we'll come together and do it. And then we'll move on to why we're doing this. That's a big old number. Right. It's not. It is 578. Chemistry all over again. Don't just keep going. Carry on. You thought you ate. Thank you, Logan. I appreciate your support as I try to get everybody loosened up a little bit and clearly not having it. You asked if this was a better class, Logan. Maybe behavior-wise, but y'all aren't quite as fun. You look kind of dull. Y'all are sitting here staring at me like. I know.
No one else wants fun. Like everyone else. Yeah, like when you know what you're doing.
I see why you said 17. I see what's going on.
I see what happened.
Yeah. You took her. But she didn't even know why she chose that. She was right in choosing it.
Because it's really great. It really helps.
All right, so the biggest perfect squares, you made your way down the list. You probably went, oh crap. You got to 13 squared and it still didn't work, and you went, what am I supposed to do? But if you kept going, 17 to the second power is 289. And you can divide 578 by 289. So that's right. That's right. So the square root of 289 is what? 17. 17. How'd you, okay. Square root of 289 is 17. So 2 times 17 times the square root of 2, which is, okay. So I started going down that list of perfect squares, right? And the list of perfect squares ended at 169, but I couldn't divide that. So then I said, okay, well, what is 14 squared? 14 squared is 196. Still can't divide 78 by that. 15 squared, 225. Still can't. 17 squared, though, is 289, and 289 times 2 is 578. This one was just hard because it was such a big number.
Okay, so I
that went in.
did it right.
Yeah. Because 289 times 2 is 578. Well, it was in the beginning of the problem, so it said multiply 3 times the square root. So what I did was whenever it keeps coming down, and now because these are outside the radical now, I can multiply them together. And 17 times 3 is 51. Nice. Square root 2 is still there, and I throw a plus or minus in front. That's your final answer. All right, get ready for why we use this, because you're going to have plenty of practice with this. The question is, why in the world do I need to know all this about radicals? Well, because I'm going to use it whenever I solve. Remember I told you the whole rest of this chapter, or this unit, was about what? Solving what? Quadratics. Tell me the ways we have solved quadratics so far.
Vertical.
Solve by graphing, and by graphing I do what? Find the close. What's the other thing we learned? The zeros. The zeros. Okay, so solve by graphing, finding the zeros. What's the other way we talked about solving quadratics? Factoring. And whenever I solve by factoring, I set each piece to 0, right? Here's way number 3. We can solve quadratics. If it lends itself to solve this way, you can't always, but today we will, solve using square roots. No, not necessarily. Before you learned about quadratics, and whenever you were just a simple little algebra 1 student learning about linear equations, and your teacher said to solve this, what would you do? Before algebra 2, before you learned about patterns and things like that, if this was a linear equation, let's pretend like the square wasn't there, how would you get it?
You would add 64.
You'd add 64. Why do you add 64? How do you know what to do and the order in which to do it? The math teacher said so. What did she ever tell you why though? Like if you had the equation 2x plus 3 equals 7.
We have to leave the variable outside.
Okay, so, but there's 2 things connected to the variable. There's a 2 and there's a 3. How do you know what to do first?
Oh, PEMDAS, yes.
You're close, but think complete opposite of PEMDAS. SADMAP. I'm going to go backwards, PEMDAS. Did no teacher ever tell you that that's why you saw? Okay.
I just always made it
To simplify something, I go order of operations, which is PEMDAS. But solving is the opposite of simplifying, so I'm going to go in the opposite order. So whenever I solve, so in a linear equation, you probably looked at it and went, well, I'm just going to start the furthest away from x and work my way to x, right? But whenever we get into more complex equations, we need to know the order that we do them and why, because it's not always quite that easy. So if I use this, it'll always work. Is there anything being added or subtracted to x in this example equation? Yes, so that's why I take care of that one first. We are, but I've regressed because I didn't know y'all didn't know the order and all. Okay, so now is there anything being multiplied or divided? Yes, the 2, so I'm going to divide, and I get x equals 2. So that's why I do that in the order that I do it. Okay, does that make sense?
Yeah.
And as I'm doing this, I'm doing what we call inverse operations, or operations that cancel that inverse. So the inverse of addition is what? Subtraction, what cancels out addition. The inverse of multiplication is division. Well, there's a new operation here. So my question to you is, what's the inverse operation of a power of 2? In other words, what cancels it out? That's a square root. So squared and square root cancel each other out. Okay? You should have. I hope you have. If I had x squared, the square root of x squared, it would just leave me with x because they cancel each other out. Okay? All right. So how do I solve using square roots? Well, this method is going to be used whenever you see only one x in the equation. Now, for right now, I'll tell you, hey, solve using square roots. On your test, whenever we get there, you'll have a section where it'll say solve using the best method possible. So if you ever see just one x in the equation, you know you can SAD map your way out of it. You can solve. So look at the very first example that's there. If I solve this using SAD map, what do I do first? We move to 64. I add 64. I have x squared equals 64. Now what? Square root them. What does x equal? Plus or minus 8. Why is it plus or minus? The square root. If you graph this, okay, if we went back and we solved this fact, remember it's different. First, add 9. 2x squared equals 64. What do you do now? There you go. X squared equals 32. Square root them. I can't stop here because I can still divide by a perfect square. What's the perfect square that I can divide by? 16. 16 and what? 2. So I get 16 and 2, which is 'cause you what? Oh, okay. So if you did, let me show you. That's a good example though. 'Cause let me show you. Let's say you did 4 and 8. Okay, and you did square root, square root. So you got 2 square root of 8. Here's the problem. You can still do this one again. If you do that one again, you can do 4 and 2, right? So now I got 2 square root of 4 square root of 2. What's the square root of 4? So now I got this 2. This becomes 2. And I end up with 4 root 2, which is the same thing. So you just didn't pick the biggest one, and that's okay. You just have to keep going. Good question, though. It's not that you can't, but if you do, you have to square root everything. So when I subtract 5, minus 5 would be what, 16? You could square root here, but then you'd have 9x equals 4. Instead, I would do this. It's not any, if you leave it as a fraction, it's easier to leave it as a fraction and then square root top and bottom than it is what you're trying to do. Try number 9. If you can get number 9, I'll shut up. It's a fraction. It is. It's going fast. Anybody get it? Did you get stuck at the fraction part? No, the first sheet's just we were working together. No. All right, let's see what we do first. SAD map through, right? So the first thing I'm going to do is subtract 1.
might get.
How do I get rid of the fraction?
You have to multiply by the reciprocal.
By the reciprocal. Never divide by a fraction. Instead, Nord stopped me with this question today. This pertains to this. I know I'm a bit ADD and I'm sorry. What's 1,000? What's 500? Oh, man. I just messed it up. Let me do it differently. What's 50 divided by 1/2 plus 9? 50, 109. That's exactly right. 50 divided by 1/2. No. 50 divided by 1/2 is 100. Plus 9 is 109. Because, yeah. We're on no, Mom. I'll tell you which ones we're going to do. All right. So the point that I'm getting to is instead of dividing by 1/2, multiplying by the reciprocal is the same thing. So here I get x squared equals 80. Now can you finish it?
What happens if your number is high on your right side of it?
We're going to get to that. That'll be the next unit we do. Yeah.
No,
But
you
is
can't
that not
do
number
that.
7?
That's,
Is that number 7? What is the answer? What is the answer?
You'd need to show multiplying by the reciprocal, yeah.
I'm telling you, I did.
Can you simplify 80?
Yes.
What and what?
16 and 5.
Ooh, what if I didn't pick 16? What if I picked 4?
Do what I did and go 400 and then go 1.
There you go. Just like this one, where is it? Just like this one where I had to keep going, I would just keep going to do it. It wouldn't be fully simplified. Oh, no points off. No.
That is you tonight for homework.
8 and 10, but 8's not a perfect square. One of the two has to be a perfect square.